We have always looked up. We have always wondered. For millennia, our eyes were all we had. We saw the moon, the planets, the endless river of stars we call the Milky Way. We told stories. We drew maps of the heavens. We felt a deep and profound connection to the vastness above us, a sense of belonging to something much larger than ourselves. But our vision was limited. We could only see the bright, bold lights in our cosmic neighborhood. The deeper, fainter secrets of the universe remained hidden from our view, waiting patiently in the dark. Then we built new eyes. We built telescopes. These incredible machines allowed us to peer deeper into space than ever before. We saw galaxies spiraling in a cosmic dance. We saw nebulae where new stars are born from dust and gas. With each new telescope, our universe grew larger, more complex and more beautiful. The Hubble Space Telescope gave us breathtaking images that changed our perception of the cosmos forever. It showed us a universe teeming with billions of galaxies, each containing billions of stars. It opened our minds to the sheer scale of reality. Now we have the James Webb Space Telescope. It is the most powerful eye we have ever sent into the heavens. It is a marvel of human ingenuity, a golden honeycomb designed to capture the faintest, oldest light in the universe. Unlike Hubble, which sees the universe primarily in visible light, Webb is designed to see in the infrared. This special vision allows it to cut through cosmic dust clouds that obscure our view. It can see the very first stars and galaxies forming at the dawn of time. It is our time machine looking back over 13 billion years into the past. The James Webb Space Telescope, or JWST, is not just about looking back, however, it is also about looking outward. It is about searching for worlds like our own, orbiting distant stars. It is about studying their atmospheres, searching for the chemical fingerprints of life. This magnificent instrument represents the culmination of decades of dreams and hard work. It floats silently in the cold, deep space, a million miles from home, waiting to show us something that could change everything we thought we knew. The question has echoed through human history, whispered in every culture and every generation. Are we alone in this vast, unending universe? Or does life, in some form, exist on other worlds? For most of our existence, this question was purely philosophical, a topic for poets and dreamers. We had no way to find an answer. The stars were too far away, our tools too simple. We could only imagine what might be out there, populating our stories with strange creatures from other planets. But science has a way of turning fantasy into fact. In the last few decades, we have discovered that planets are not rare. In fact, they are everywhere. We now know that most stars in our galaxy have planets orbiting them. We call these worlds exoplanets. Thousands have been confirmed, and there are likely billions or even trillions in the Milky Way alone. Some are giant balls of gas, like Jupiter. Others are frozen worlds of ice. And some are small rocky planets, like Earth, orbiting their stars in the habitable zone where conditions might be just right for liquid water to exist. How would one even begin to look for city lights on a planet trillions of miles away? The challenge seems immense. An entire planet is just a tiny pinprick of light next to its brilliant star. Any artificial light from its surface would be unimaginably faint, like trying to spot a single firefly next to a powerful searchlight from miles away. However, the James Webb Space Telescope has changed the game. Its incredible sensitivity to infrared light gives astronomers a new set of tools. Many forms of artificial lighting that a civilization might use, such as sodium vapor lamps or even more advanced technologies, would emit a distinct signature in the infrared spectrum. Webb can separate the light of a planet from the light of its star. It does this by observing the planet as it moves in its orbit. By carefully measuring the total light from the system, astronomers can detect tiny changes as the planet passes behind its star or emerges from its shadow. The key is to observe a planet through its full orbit. As the planet rotates, different parts of its surface face us. If a planet has a day side and a night side just like Earth, we can measure the light coming from each. The day side reflects the star's light, while the night side should be completely dark. But what if it is not? What if astronomers detect a faint, persistent glow coming from the planet's night side? This could be the telltale sign of widespread artificial illumination. A planet lit up by its inhabitants. To be certain, astronomers would have to rule out all other possibilities. This is where the data becomes crucial. City lights would have a specific spectral signature, different from natural sources. Proxima Centauri is the closest star to our Sun, a mere 4.2 light-years away. In cosmic terms, it is our next-door neighbour. It is a small, cool red dwarf star, much dimmer and older than our Sun. For years we have studied this star, wondering if it too might host a family of planets. In 2016, that question was answered. Astronomers confirmed the existence of a planet orbiting Proxima Centauri. They named it Proxima Centauri b, or simply Proxima b. It is a small, rocky world, slightly more massive than Earth, and it orbits its star in the habitable zone. This was a monumental discovery. However, there are challenges. Proxima b orbits its red dwarf star very closely, completing a full year in just 11 Earth days. This means it is likely tidally locked, with one side perpetually facing the star in endless daylight and the other side trapped in eternal night. The star itself is also known for violent flares, which could strip away a planet's atmosphere. Despite these challenges, Proxima b became a prime target for the James Webb Space Telescope. Its proximity makes it one of the easiest exoplanets to study in detail. Not long after Webb began its scientific operations, a team of astronomers dedicated hundreds of hours of observation time to this fascinating world. Their goal was simple, yet profound. They wanted to measure the thermal emission from the planet as it orbited its star, hoping to map its temperature and determine if it had an atmosphere. They were not looking for city lights. They were just trying to understand the basics of this alien world. The process was painstaking. Webb stared at the Proxima Centauri system, collecting photons one by one. The data streamed back to Earth, a flood of numbers to be processed and analyzed. The team carefully subtracted the overwhelming light of the star to isolate the faint signal from the planet. They watched as the planet moved through its phases, from a full-day side view to a thin crescent. As the planet's night side began to turn toward us, they expected the light to dim to almost nothing, but it did not. Something else was there. A faint, steady glow coming from the side of the planet that should have been shrouded in absolute darkness. The initial data was met with cautious skepticism. In science, the most extraordinary claims require the most extraordinary evidence. The team of astronomers checked everything. They recalibrated their instruments, they reviewed their models, they looked for any possible source of error or natural explanation that could account for the anomalous light. Could it be thermal radiation from the planet's dark side? Perhaps, but the signal was just too strong in certain parts of the infrared spectrum, and it did not match the expected heat signature of a rocky, tidally locked world. They continued to observe. For months, Webb returned to Proxima b, gathering more and more data. A pattern began to emerge from the noise. The light was not uniform. It was concentrated in specific regions on the planet's night side and also along the terminator, the line between day and night. This twilight zone would be a place of perpetual dawn or dusk, maybe the most hospitable region on a tidally locked planet. The distribution of the light was not random. It seemed to follow what might be coastlines or land masses, forming interconnected networks of brightness. The spectral signature of this light was the most startling piece of the puzzle. When the astronomers broke down the light into its constituent colors, they found clear spikes that corresponded to the emission profiles of certain elements. These were not the signatures of natural atmospheric gases. Instead, they bore a striking resemblance to the light produced by specific types of artificial lighting technologies we have considered or used on Earth. It was as if someone had left the lights on. The evidence was pointing toward a conclusion so profound it was almost terrifying to consider. After nearly 2 years of rigorous analysis and peer review, the team was ready to announce their findings. The paper was published, and the world stood still. The news rippled across the globe, first through scientific communities and then to the public. Webb Telescope detects possible artificial lights on Proxima b. The headlines were cautious, but the implication was clear. Humanity may have just found the first credible evidence of an extraterrestrial technological civilization. We were no longer just looking at a point of light. We were looking at a place, a world, possibly a home. So, what did we really see? It is crucial to approach this discovery with both wonder and scientific rigor. The data from the James Webb Space Telescope indicates a faint, persistent source of infrared light emanating from the night side of Proxima b. This light is not consistent with known natural phenomena such as auroras, volcanic activity, or simple thermal radiation. Its spectral signature contains narrow emission lines that suggest an artificial origin, and its distribution across the planet's surface appears non-random and concentrated, as one might expect from urbanized areas. The most compelling theory is that we are observing the glow of a planet-wide civilization. On a tidally locked world, the most advanced life might choose to live in the twilight zone, where temperatures are more moderate. The lights we see could be from vast cities, industrial complexes, or perhaps even agricultural centers that require artificial light to grow crops in the permanent darkness of the planet's far side. Of course, we must remain open to other possibilities, even those we cannot yet imagine. Perhaps there is some exotic geological or atmospheric process on tidally locked red dwarf planets that we do not understand. A process that perfectly mimics the light of a technological society. Science demands that we try to disprove our own theories. The burden of proof is immense. Future observations will be needed to confirm these findings. We will need to map the light with even higher resolution and monitor it for changes over time. Do the lights flicker? Do they grow or shrink? This discovery, even if it remains a candidate signal for years to come, has already ignited a new fire in astronomy and science. It provides a specific, testable hypothesis. It gives us a place to focus our search, a cosmic doorstep to examine more closely. It is a call to build even more powerful telescopes, perhaps arrays of instruments working together to create a virtual lens large enough to directly image the surface of Proxima b. The question has shifted from, are they out there, to who are they and what is their world like? The journey of discovery has just begun. The confirmation of city lights on Proxima b would be more than just a scientific discovery. It would be a turning point for our species, a moment that fundamentally realigns our perspective of ourselves and our place in the universe. For our entire history, we have operated under the assumption that we are alone. This idea is woven into our religions, our philosophies, our cultures, and our science. It is the silent backdrop to all of human endeavor. To learn that we are not alone, that another intelligent species coexists with us in the cosmic dark, would shatter that foundation forever. The impact on science would be immediate and revolutionary. The field of astrobiology would transform overnight from a field of theoretical possibilities to one of practical observation. We would have a second data point for life, a second example of a technological civilization. By studying their light, we could begin to learn about their technology. By studying their planet's atmosphere in more detail, we could search for signs of their industry and perhaps even their biology. Every field from physics to sociology would be faced with new, profound questions. For humanity as a whole, the discovery would be a mirror. It would force us to look at ourselves in a new light. How would we react? Would it unite us, reminding us that we are all inhabitants of a single, fragile planet? Or would it frighten us, leading to new divisions and anxieties? The knowledge that a civilization exists just next door, a civilization potentially far older and more advanced than our own, would be a humbling experience. It would underscore the importance of our own survival and our stewardship of planet Earth. This would be our generation's Copernican revolution. Just as Copernicus showed us that Earth is not the center of the universe, this discovery would show us that humanity is not the sole proprietor of intelligence. We are part of a larger cosmic story. Our existence is not a singular miracle, but perhaps one of many. This realization could inspire a new age of exploration and creativity, a renaissance of art, science, and philosophy as we grapple with the knowledge that we have neighbors among the stars. Our world would never be the same. The stars have always inspired awe. They are distant, mysterious, and silent. For so long, we have shouted our questions into that silence with no expectation of a reply. We have sent our probes, our radio waves, and our dreams out into the void, hoping to find a sign, a whisper, a kindred spirit looking back. We have felt profoundly alone in a universe that seems indifferent to our existence. The silence of space has been both a comfort and a source of deep existential loneliness. We have been the only voice we know, but now the silence may have been broken, not by a message, not by a spaceship, but by a gentle, persistent glow 4 light-years from home, a light that tells a story of another world, another history, another form of intelligence that rose from the dust of its planet to build, to create, and to light up its night. This faint flicker from Proxima b is a profound reminder that the universe is not empty. It is filled with potential, with wonder, and perhaps with neighbours we have yet to meet. This journey is far from over. In fact, it has just begun. The light from Proxima b took over 4 years to reach us. Any message we send would take the same amount of time to get there. A conversation would span generations, but perhaps that is the point. This is not about a quick chat. It is about joining a galactic community, about taking our first tentative step onto a much larger stage. It is about understanding that the story of life is not just our story. It is a universal story, and we are privileged to be a part of it. So, the next time you look up at the night sky, remember this. You are not just looking at random points of light, you are looking at other suns, you are looking at other worlds, and one of them, our very closest neighbour, might just be looking back, its own lights shining as a quiet testament to the fact that we are not alone. The universe is a vast and wondrous place, and we have so much more to explore. Our search continues with more hope and excitement than ever before. If you found this journey through the cosmos as inspiring as I did, please consider liking this video and subscribing to our channel for more explorations into the biggest questions of the universe.